Okay, students, can you hear me?
Yes, doctor.
Okay, so there are only 29 of you. I'm not sure what happened to the rest, but I can tell you straight away that everybody needs to be here to listen to this one. Because why? Because there will be a major change in the procedure, which you are going to write down in your lab report. So for the others who are still not here, do them a favor, remind them. Otherwise, they will have to copy from your report, which I don't recommend you to help them like that. Ask them to come in and ask them to listen to themselves. Don't share what you hear right now. Okay, now I'm going to tell you what are the changes that you need to make on top of your own lab manual that you're having. So the rest that you're looking here, beginning from the objective, the title, and also the introduction remains the same. What changes starting from the next page, which is right here. So the apparatus, number one, is not going to be used at all because photometer is an inferior equipment for the detection of sodium. So the new instrument that we're going to use, as I have mentioned to you before, is Icp-Oes. I just want to ask you before I continue, how many of you have learned the introduction at least something about Icp-Oes before this? Does anybody learn this before? Yes or no?
No.
No, sir.
Okay. Did you learn did you enroll instrumentation? There's a code called instrumentation. Have you enrolled that code before? So what is your answer? No, or you don't know? Okay, I think I'll take some time to understand lah. If you have your pelan pengajian, okay, your pelan pengajian, take it out. We'll take some time and we'll go deep into this one. Take your pelan pengajian and tell me, is instrumentation one of the subject that you need to enroll for your degree? Okay, do me a favor. Open up your lesson plan. Bukan lesson plan, pelan pengajian. And then tell me, ada.
Ada, doktor.
So dah ambil ke belum?
Dapat PC.
Okay. So you did your instrumentation before this, either when you're in diploma or when you are in matrix or pre-U lah. So masa instrumentation tu, you haven't learned about ICP ke? Ada tak? Icp-Oes or Icp-MS, pernah belajar tak? Masa instrumentation. Okay guys, we're wasting time. Ada ke tak ada?
Ada.
So ada lah, cuma you all tak ingat kan? Alright. So by right kan, I wouldn't be too concerned because I thought you tak pernah belajar pasal ICP, which I'm surprised. Because if you don't get PC kan, for sure that is one of the major equipment. Because why? That is the only equipment apart from AAS. These two equipment saja that you will be able to use to determine the metal sample, any metal. This time is sodium from any sample. If it's liquid, oh, by the way, the sample have to be liquid, so that's why our sample for this CEC experiment is from the ammonium acetate, which you already collect, and then only you're going to send it for analysis. So if you say you have learned about ICP, for sure one of the things that you learn is how to use it. So it's just the same as any equipment lah. This is why I'm going to show you lah ya. Number one, flame photometer gantikan dengan ICP. I nampak flame photometer, I terus potong markah ya in your method. Okay, done. Now the rest of it is also the same. Now I pull you straight to this following page, the stock solution. Let me see. Okay, so stock solution also change because I remember yesterday the sodium stock standard solution. So gantikan nama ni, bukan standard stock solution is the one that is collected. So it is collected from the lab assistant who takes care of Icp-Oes. But I couldn't recall what was the concentration of that stock. So does anybody here remember what was the concentration? Siapa yang ambil saya lupa dah semalam.
1000
ppm ya. Okay. So it's 1000 parts per million. In other words, parts per million ni in SI unit siapa tahu? SI unit parts per million for liquid sample. Apa SI unit dia? Tahu? Yeah, you all belajar water resource technology, sepatutnya tahu kan? Parts per million, SI unit. Okay lah, I bagi tips. It's going to be mass over volume. So the mass will have to be gram lah. Milligram, kilogram, apa gram, okay, bahagi dengan volume, which is liter. So how many grams per liter? 1000 berapa? What is the unit of that gram?
Is it milligram per liter, sir?
Yes, that is correct. 1000 milligram per liter. That is ppm unit. Now we're dealing with Icp-Oes that we're playing around is ppm. But if it is a more sensitive equipment like Icp-Ms, the other ICP, they can detect up to parts per trillion, which is microgram per liter. Okay, enough of the introduction lah. These are the things that you should have learned masa instrumentation tu. Now, once again, the initial concentration for stock solution 1000 ppm or 1000 milligram per liter. That one you have to put it inside your lab manual. Your report, your lab report. And then after that you will need to calculate. So after this, you guys will going to calculate lah. Now that you have access to computer, senang-senang lah you can open AI kan, and bagi tahu lah dia. Okay, AI, you have stock solution, stock standard sodium solution 1000 ppm. You have to prepare a few concentration kan, which right here they say you need to dissolve apa. No, this lab manual asks you to prepare the standard by diluting the sodium chloride. That one I won't recommend lah, because why? Usually this will be not very accurate. The most accurate is usually we dilute from the standard yang kami beli. If they say 1000, memang betul-betul 1000. Tak ada plus minus punya. Memang accurately 1000. You just need to dilute accurately. Now Speaking of which, dilution, we're going to use deionized water, and only deionized water, not distilled water. I'll leave that question for you. Why? Why we have to use deionized water and not distilled water? And then, what concentration? So, the concentration that you're going to dilute to is not like you see in 1C. Tak. We were going to prepare only 4 concentration. Actually 5, but the last one doesn't count as concentration because the last one usually is just nitric acid. Nitric acid, or you also can use deionized water, which the concentration is 0 ppm. Okay, you need 5 kan? To set up the calibration curve, you need 5. The lowest, or what I say, 0 ppm. The highest for our ICP lah, dia boleh handle sampai 10 ppm saja. The highest possible concentration that they can detect and confidently accurate is only 10 ppm. Because our Icp-Oes is quite old, not very sensitive, and we test it so many times, dia hanya boleh baca sampai 10 ppm secara tepat. If you have more than 10 ppm, they still can return some reading, cuma dia out lah sikit. Yeah. So we're dealing with one equipment that not very sensitive, and we have to adjust lah the concentration of the standard. First of all, the standard. So kalau lah your lowest is 0 and the highest is 10 ppm, what are the middle concentration below 10 ppm, between 0 and 10 ppm? What are the concentration will you propose? Kami nak 5 point. 0 dah ada, 10 dah ada, nak 3 lagi. So what are the concentration do you propose? Cepatlah. Senang je kan?
2, 5 and 8. So,
You can pick 2, 5 and 8. You can also pick 2, 4, 6, 8 kalau nak lebihkan. So it's all up to you, because after all you are the one who do the calculation kan. So after this kan, or maybe shall we decide right now semua sekali, what are the concentration do you want to pick? And actually kan, by the way, you don't have to be necessarily following exactly what I said, because I propose 5 points kan. Actually the calibration curve ni boleh establish even with 4. That means 3 concentration, 1 0 dan 4 point boleh jalan je, no problem. But jangan 3 data points is not strong enough statistically to establish a good calibration curve. You must have recommended 5, kurang 1 tak apa, 4. So what do you think? 3, 5, 8 or 2, 4, 6, 8, or 3, 5, 8 ke? If that is what you want. Semua confirm ke 3, 5, 8? I don't have a problem with 3, 5, 8. Although my other students at FYP, they are also preparing a nickel standard, not sodium, and they will prepare 2, 4, 6, 8. Lebih banyak data point, which is I prefer that way. But if you want to use 4 data point, 3, 5, 8 also can. Tak ada masalah. Can. Okay, now you say you want 3, 5, 8 ppm kan? Okay, 3, 5, 8 and 10 ppm. So catat, semua orang kena catat tau. 3, 5, 8, 10 ppm. This will be the calibration curve data points that you want to set up, and you will need to dilute from 1000. Tadi stop 1000 kan, so you have to dilute from 1000 down to 3, 5, 8 and 10 ppm. So kena main dengan M1, V1, M2, V2 lah. So M1 you dah tahu 1000 ppm, M2 3, 5, 8 or 10 ppm. So ada 4 kiraan. Now what about the volume? Because now you need to know how much of 1000 ppm and you want to know how much of volume of the standard needed for the calibration. So you will need around 15 ml. 15 ml, 15. Okay, 15 ml. Actually kan 10 ml pun cukup. I would say mana lebih senang? You nak dilute to 15 ml ke ataupun you nak dilute to 10 ml? So, berapa?
10.
Nah, 10 ml ya. Okay. If you want to dilute to 10 ml, then you have the V2 lah kan? V2 is 10 ml. So you can do the calculation, betul tak sekarang? Kan? Okay, sebenarnya kan you don't need to do the calculation lah. You just feed all this information to AI, suruh dia calculate, tengok macam mana. So once again M1 1000. V1 that is the one that we want to calculate. Okay? V1 is what we want to calculate. M2 is either 3 ppm or 5 ppm or 8 ppm or 10 ppm, and then the V2 will be 10 ml. So suruh AI kirakan. Okay, and then tell me what are the volumes of the 1000 ppm sodium that you need to dilute to 10 ml. So cepat, AI ni cepat, jawab cepat. Cepatlah, nanti lambat korang nak prepare standard pula. Oh, did I disconnect myself? Tak ada orang jawab. I'm talking to myself.
Ada doktor tengah cari.
AI ni kalau you feed in all this information kan cepat tau dia cari. So what is it?
After we use the 0, 3, 5, 8 and 10 sir, for V1 we got 0, 0.03, 0.05, 0.08 and 0.1 for V1.
Those are in ml ke? Or what?
I've inserted it in ppm, but I think I need to make it more specific lah, but that's the volume that we got for V1 after inserting all of the equation that is given.
Okay. Did you calculate manually or you use AI?
I use the AI generator.
Okay. Now so you said earlier is 0.03 kan to prepare 3 ppm. Did you say that?
Yes.
Okay, I assume that is ml lah kot. So dilution factor 10 ml bagi 0.03 kali dengan 1000. Lain je. Sekejap, 10 ml divide by 0.03. I don't think that is the right calculation. 1000. Never mind, I will try myself. Let me check one more time. I will try it. 1, 2, 3, 0.03 ml dilute to 3, 5, 8 and 10 ppm. Okay, give me a minute. Once I finish with this, then I will show you what I got from my script. Okay, let me stop with the video sharing and I'm going to share my entire screen lah senang.
Doctor,
Hmm?
the M1 is 1000 and M2 is 10 and V1 is unknown, V2 is 10, am I right?
Yup.
M2 is 10, 8, 5 and 3.
10, 8, 5 and 3. What unit are we talking about here?
For M2 guna 10 ada, Doctor.
V2 not M2. V2 is 10 ml.
Oh,
Okay, actually earlier lah, I actually used AI to calculate the stock solution from 1000 with dilute to 2, 4, 6, 8, 10 ppm. So itulah the unit there, but you say you want to choose 3, 5, 8 and 10 kan. So everybody can see my AI screen kan, ChatGPT. Boleh nampak kan? Boleh nampak tak?
Nampak.
Okay. So now this is a formula as you know, but in order to calculate accurately kan, I usually don't calculate formula by formula. I use table. Ni baru jelas. So if you want to take 3, 5, 8, 10 ppm in the graph, first column, the stock solution macam yang Wan cakap tadi lah, 0.03, 0.05, 0.08, 0.1 dilute to 10 ml. So you kena tambah lah berapa ml water that you need to put in. Volume of ppm, 1000 ppm, microliter. So in terms of ml, sekian-sekian, but you were going to play around with this unit lah, microliter, because you were going to use micropipette lepas ni. I just want to ask before I continue, anybody here have never used micropipette before? Lepas ni maybe boleh datang dan tengok lah. Now, I have asked each group to send 2 person to prepare for the standard kan. So make sure that 2 person that you're sending have used micropipette before and know how to use it. Yeah, pastikan. Where can you get the micropipette? They are in water lab. Water lab ada. The issue is the tips. Tips tu, you will have to wash it and you have to use a clean one. Dia kena baru. So maybe 1 tip is enough because just 1 metal kan, the stock. So you have to draw lah 30 microliter, 50 microliter, 80 microliter to 100 microliter of the stock solution. And then you add lah with the deionized water 9.97, 9.95. Then total up semua ngam-ngam 10 ml. And you are going to put all this inside the small centrifuge tube. Volume dia 15 ml. So lebih besar lah bekas tu. You can fit this 10 ml easily. Setengah je lah. Okay, so make sure you label lah ya, the concentration according to this table right here. And not to forget there's one, which is 0 ppm, your deionized water. Okay, so setakat this table, jelas kan? I'm sure you can. I'm sure you can like generate yourself, or maybe you can print screen dan lepas tu paste kat mana-mana. But I want this exact thing that you have planned to be the exact procedure in your lab manual. Tak ada lain. Don't copy the one in the lab manual. Dah berubah ke sini. So this is your standard. The calibration curve. I will see if this can generate. Sepatutnya dia boleh generate calibration curve lah. Oh, dia tak ada. Okay, dah keluar. Now, let's say lah, if the calibration curve is what you can see right here, you're going to start from 0 asalan, and then it will be a straight line. So the highest point that you can see here is up to 10 ppm. Okay, now what is important in this calibration curve is like, this curve will be proportional. The higher the signal, the higher the concentration means. And based on this curve, the computer will use this slope, dia punya kecerunan dia, the slope, to compute and calculate the concentration in your ammonium acetate liquid sample. So it is very important that this curve pass through the asalan, the origin, asalan 00 right here, and then the R square, dia punya correlation coefficient, the R square will have to be as near as possible to 1. And how near do we need to be? Okay. So 1 is absolute 1, and usually inside this calibration curve, your correlation coefficient will usually be 0.999949 and whatnot. Anything less than that, kalau kurang 19, you still continue, but that means your analysis is subjected to error. Sebut pasal error, you should know what to do, kan? And that is why I want to brief you on this one. You will only be able to talk about error based on the calibration curve that you are about to get. So bila dapat calibration curve, jangan letak tepi tau. You have to talk about what error, ada ke tidak. I don't want to say ya ataupun tidak. You discover yourself. You kan ada AI kan. Just use it. Okay. So now you have calibration curve, and inside the analytical chemistry lah, when you use this when you use this ICP, we usually going to check the performance, just like what you did when you determine the pH and also EC. Some did not. So I want to highlight to this one lah. Now, once you have prepared this standard solution, the last part that you are going to make sure you adjust is step number 9. Run the Icp-Oes, not flame photometer. And then don't ask me whether what is wavelength. No, these are all can be removed because we no longer use photometer. This equation also can be removed because we are not going to calculate using milli equivalent per 100 gram unit, but rather we're going to calculate using unit centimole per kg. I'm sure you know lah, when you look back at the lecture slide about CEC, there's another unit. Calculate in centimole per kg. Okay, now moving on to the next sheets, table 4.3a. You will know you don't need to fill in this table at all, but you have to show me the calibration curve coming from the ICP. Show me the image, the plot of the calibration curve, just like what you saw just now. Yeah. And then once again, you will need to use the R square to discuss whether error is present. That is number 1. Step number 2, also to discuss the presence of error, is you check the performance of the calibrated ICP. So after the calibration curve is recorded, you can still check it, and actually you need to by using any one of the standard that you prepared. You can choose lah 3 ppm ke, 5 ppm ke, 8 ppm or 10 ppm ke, and you were going to use that same standard and you check it. Check it means you are going to analyze the standard as if you analyze it as one of your sample. So if the result comes up, let's say you nak pergi analyze 10 ppm, okay, that 10 ppm standard, Result keluar 9.95. Ya, 9.95 ppm. Dia out sikit. Dia off by 0.05 ppm. The question is, ada error tak? What do you think?
Ada.
Betul, ada. Tetapi significant tak? Significant ke error ni? Dia off by 0.05 ppm. Significant tak? Tak pasti kan? It's okay. To me, from the 10 ppm, kalau dia lari by 0.05 ppm, saya pejam mata saja. Because why? You use that 0.05 ppm and you calculate CEC in centimole per kg. Tengok berapa nilai tu. Kalaulah dia off 5 ppm kan, berapa banyak larinya nilai CEC sekiranya nilai ppm dia underestimate by 5 ppm. Buat sendiri. Lepas tu you bagi tahu yourself lah. And then you ask yourself, with that much of CEC value off, significant tak? Lepas tu you write your lab report in terms of the error analysis. So I will leave all this question for you. Photometer out, table 4.3a out. You got your formulation just now, which is right here. Yeah. You got your formulation, which is right here. That is the formulation. Yeah, this one. This formulation. Make sure you prepare this standard as best as you possibly can. And then the date, tarikh untuk hantar ICP ni is next Monday. Monday akan datang. Not today. Today you prepare the standard, Monday you hantar terus saja. Okay. So may I know who is going to prepare this standard? Nama mereka perlu dicatat di sini. Nak appoint ke? Ke belum?
Belum, Doktor.
Okay, kalau belum, then lepas ni korang decide. So tadi saya dah cakap, sesiapa yang terlibat dengan filtrate akan stay on dalam sesi yang sama untuk perbincang pasal filtrate. Yang selebihnya, korang pergilah prepare the standard. Lepas ni, kalau boleh share the video or the pictures of you how you prepare that. To me, these are basic chemistry, basic lab work that you need to prepare. But for those who haven't have any hands-on experience kan, I encourage you to join them in preparing this standard. And then once you prepare this standard, you cannot send today kan, so you have to keep it inside the fridge. Now while you keeping this, because we have a 3-day gap before we analyze this one, that means we need to preserve it. So tell me, what is just one preservative? What is the preservative that you need to put into your standard and also your sample? What is that chemical? Ingat lagi ke the water sampling and also preservation? Ada kaitan. So, nak letak apa?
Acid,
Mana satu?
nitric acid.
Betul. And remember, one drop of concentrated nitric acid. That's it. Jangan lebih just one drop. Setiap satu tau, standard and also your sample. Okay, now I noticed that from the picture that I saw earlier in WhatsApp, your sample is quite cloudy. So again, kalau tak nak kena marah dengan lab assistant, baik korang filter siap-siap lepas ni. Every single liquid sample that you have, nampak sedikit habuk, cloudiness inside there, automatic filter. Okay, that's buat. Number two, the liquid that you filter kan semua dalam volumetric flask 100 ml. Tapi korang tak perlu hantar ke semua 100 ml tau. You just need to send 10 ml saja, sebagaimana the volume of your standard. Just 10 ml. So filter cukup-cukup 10 ml, masukkan ke dalam centrifuge tube kecil, the small version of the centrifuge tube, which is 15 ml. Yang besar 50 kan, yang kecil 15. Yang tu masukkan dalam centrifuge tube kecil, dan lepas tu tutup dengan parafilm. Parafilm tahu tak?
Tahu.
Kena tutup ya, because why? Kalau tak tutup dia akan kering. Habislah lepas dia kering. Volume dah lari. Kena tutup. And make sure that everything that you put inside there, most importantly your standard, you will have to mix it. Kena pastikan dia bercampur. Because let's say kan, kalau korang letak distilled water siap-siap dalam centrifuge tube, lepas tu atas tu beberapa sedikit saja korang punya stock solution tanpa campur, dia akan tak boleh detect tau. The actual concentration dia tak sama. So you have to make sure that you mix well. Now the technique that I use lah in order to make sure this does not happen is I will put in the stock standard dahulu, lepas tu baru curahkan the deionized water. So at least kan deionized water tu banyak, bila dicurah tu dia bercampur lah automatic. Tapi kalau you letak deionized water dahulu yang banyak, atas tu sedikit the stock, dia tak bercampur, habislah. Nanti lain dia punya calibration. So those are tips number 1. Okay, tips number 2, once again, you filter lah. Any sample that you don't have trouble with fluctuation or have a blocked vessel inside ICP dan rosakkan ICP, memang setiap liquid sample untuk ICP tu wajib ditapis filter. And apart from filter, it's best practice for you to put in 1 drop of nitric acid just to preserve it and maintain that your sodium sentiasa sodium dan bukan jadinya sodium carbonate. Bila jadi sodium carbonate, maybe dia jadi habuk-habuk halus dekat dasar. So prevent that. I think that is it. Now, the stock standard is in the fridge outside of my room. Can come anytime. What else? Oh yes, I have also 4 more samples from Icp students that also cloudy, and I need your help to help filter them. So minta tolong sangat-sangat for those who are going to prepare standard and also filter sample, tolong filterkan bagi pihak mereka, because on that day kat masa tu tak ada filter. So okay, I think what I need to tell you is already right here. Dah selesai. Cuma satu kerisauan saya. Now, from my experience kan, last semester, semua student yang buat eksperimen CEC ni, dia punya concentration tu terlalu tinggi sampai ICP tak boleh dah detect. Dia kalau sodium terlalu tinggi, ICP tu akan auto shutdown. Jadi bagi mengelakkan perkara yang sama berlaku, saya cadangkan sampel korang yang masih ada dalam volumetric flask tu, korang pun dilute lah siap-siap. Okay, tapi persoalan dia, berapa banyak dilution factor? Saya cadangkan korang dilute by 10 times. Bermaksud tadi nak 10 ml kan, so korang dapatkan 1 ml daripada volumetric flask yang dah filter tu, dilute sampai 10 ml. So buat yang itu dahulu, semua sampel korang ya, faham tak? Boleh faham ke? Korang ni faham ke tidak ni? Diluting your sample.
Faham.
Okay, dengan anggapan korang semua faham kan, so semua dah boleh start lah kalau macam ni. And anyway, I will stop the recording because this one also I will pass it to ICEP students for them to listen. And the good news is I also enable our session to be transcripted. So kalau tak faham, nanti ada minute lah yang korang boleh refer lepas ni. So any question, refer to that one. Yeah, tanpa melengahkan masa. If there's no question for you, then I think we should end our session, and then after that we'll continue with the face-to-face discussion for EVT 536, our field trip organization, for tomorrow as well. While the rest of you dah boleh mulakan kerja lah ya. So once again, the stock solution kat fridge depan bilik saya. Lepas tu semua dilution tu korang buat kat B218 lah, the water lab ya. Okay? Dah? Let's start the presentation. Dah okay lah. Korang boleh keluar dah.
Thank you, Doktor.
Okay.